Hello and welcome back to another video. So this video is basically a quick crash course on all the organic chemistry that you need to know for IGCSE. Now, if you want a complete in detail video where I explain all these notes, you can refer to this playlist. This video is just a quick go through, so it will be a good revision for you right before your exam. Let's begin. Let's start by discussing what is organic chemistry. Organic chemistry is basically the branch of chemistry that deals with carbon only. An organic compound must have carbon in it. Now we have the first category of organic compound is hydrocarbon. It has only hydrogen and carbon. It can be divided into saturated and unsaturated. Saturated has the maximum hydrogen atoms. That means it only has single bonds. On the other hand, unsaturated has less hydrogen atoms because there is a double bond. So there you can see this has 2 carbon have 6 hydrogen, whereas here 2 carbon have 4 hydrogen. We have 2 less hydrogen because there is a double bond, and each carbon can only have 4 bonds to it, so that's why it cannot attach 2 more carbons to it. Now, the saturated hydrocarbons are known as alkanes. They have single covalent bond between carbon atoms, while unsaturated hydrocarbons are known as alkenes. They have a double bond between carbon atoms. The general formula for alkanes is CnH2n plus 1, where n is the number of carbons, and the general formula for alkenes is CnH2n. So if you have n is 1, you have methane. This is a molecular formula CH4, and that's the structural formula. When you have 2 carbon atoms, it's called ethane, it's C2H6. When you have 3 carbons, it's called propane, C3H8. And when you have 4 carbon atoms, it's called as butane, C4H10. What about alkenes? You cannot have 1 because an alkene must have a double bond between 2 carbon atoms, right? So you need to have at least 2. You cannot have methane. You can have ethene, which is C2H4. You have one double bond. You can also have and then if you have 3 carbon atoms, it's called as propene. You have 3 carbons and 1 double bond between any one of these carbons. If you have 4 carbon atoms, the molecular formula would be C4H8, but the structural formula can be different. If you notice here, you have 4 carbon atoms in the center, but the double bond is between the first and the second carbon. You can name them. You can start number it. It's 1, 2, 3, 4. You have to say it's called but-1-ene. You cannot say but-2-ene even though the double bond is on the second carbon. You have to take the smaller number. And you cannot also start from the other side. That means it cannot be 1, 2, 3, 4. You have to start numbering from the carbon that is closest to the double bond. So another possibility is here when you have the double bond on the second carbon. It's called as but-2-ene. Okay, now you have another category of organic compound. This is called as alcohol, and alcohol is not a hydrocarbon because this is the general formula, CnH2n plus 1 and OH. You have a hydroxyl group in alcohol. If you have 1 carbon atom, it's called as methanol, CH3OH. If you have 2 carbon atoms, it's called as ethanol, C2H6OH. If you have 3 carbon atoms, it's called as propanol, C3H7OH. And if you have 4 carbon atoms, it's known as butanol because C4H9OH. You can have a look at these structural formula as well. Now we have another category of organic compound. This is carboxylic acid. Again, it's not a hydrocarbon because you have oxygens here. The general formula is CnH2n plus 1. And then you have COOH. This is called as the carboxylic group, and this is what it looks like. C double bond O and then OH. It can start with, even if you have with 0, this is called as methanoic acid. That means you will place, instead of N, you will write 0. This is what the structural formula would be like, HCU double bond OH. If you choose N as 1, it's going to be ethanoic acid, CH3COOH. If you have 2, you have propanoic acid. If you have 3, it's called as butanoic acid. This is the carboxylic group. Now, if you notice, alkene has a functional group of double bond. Alcohol have a functional group of OH, hydroxyl group, and carboxylic acid have a functional group of carboxylic group, this one. These are known as functional groups, which is basically an atom, group of atoms, or a bond that is characteristic of an organic compound. It is also the site of chemical reaction. That means when chemical reaction occurs, it occurs here. If a chemical reaction occurs on this ethanoic acid, it's going to attack this area, okay, the carboxylic group. Now we can discuss isomerism. In isomerism, the molecular formula is same, but the structural formula differs. For example, if you look at the molecular formula, it's C2H6O. Structural formulas are different. You have ethanol, you have two carbons, 1, 2, 3, 4, 5, 6 hydrogen and 1 oxygen. But since you have an OH group, it's a ethanol. On the other hand, you don't have an OH group, oxygen is in the center. This is called methoxymethane. These are different with different chemical properties. Isomerism compounds with same molecular formula but different structural formula. Next is a small activity. We have to draw all the possible isomers of C5H12 and also name them. Pause the video if you like to do this. If you are done, the first one, 1, 2, 3, 4, 5, with 5 carbon atoms, you don't need to name this. And then you have 2 methyl butane because the methyl group CH3 is on the second carbon. And then you have 2,2-dimethyl propane. Why? Because the central chain is propane. It has 3 carbons, and then it has dimethyl because one methyl group, another methyl group, and then 2 because it's on the second carbon. Both of the methyl groups are on the second carbon. 1, 2, 3. Now you can also have isomerism in alkenes. So I have given some examples here. This is butene C4H8. First, you can have a single chain. This is known as but1ene because the double bond is on the first carbon. Remember, we have to start numbering from the carbon that is closest to the functional group. Then you have but2ene. It's on the double bond is on the second carbon, and then you have 2-methyl prop1ene. Why? Because first you have prop1ene, the central chain, propene because you have 3 carbons, and then the double bond is on the first carbon. And then as a side chain, you have a methyl group because it's 1 carbon, and it is on the second carbon. 1, 2, 3. You have to number the main chain 1, 2, 3, and then you have a methyl group. If you want, you can also number it like this 1, 2, 3, and your methyl group is again on the second carbon. Okay, now if you notice, if you have alkanes, alkenes, alcohol, and carboxylic acid, and I wrote down their molecular formulas. If you notice, every successive members differ by CH2 group. So CH2 is added as you move downwards. So you can see these are basically homologous series. The homologous series of alkanes, alkenes, alcohol, and carboxylic acid. You notice they have some similarities. First, you need to learn these, okay? Successive members differ by CH2 group. Then members have the same general formula. That's also correct. There's a specific general formula for alcohol, which is different to alkanes and alkenes and carboxylic acid. And then they show a gradual change in physical properties. If you notice, as you're going down, the molecular formula is increasing. The melting and boiling point will be increasing. More density, stronger intermolecular forces between them, and so on. But they are similar in chemical properties because their functional group is same. So it's a functional group that is being attacked when chemical reaction occurs. Now let's discuss the reactions of alkanes. The first one is combustion. A hydrocarbon on complete combustion gives carbon dioxide and water. You can look at these. You're getting carbon dioxide and water only. Then you also have substitution. For example, methane plus chlorine in the presence of sunlight is going to give us chloromethane and hydrogen chloride gas. You need to have sunlight. Sunlight is a must for chemical reaction. Now, if you notice, the products of this substitution reaction is not always pure. That means you won't just get chloromethane. Why? Because many chlorine substituted products are formed, and hydrochloric acid is also the product. Methane reacted with chlorine in the presence of sunlight to give you chloromethane. Now this chloromethane will react with chlorine again and give you dichloromethane. Dichloromethane will react with chlorine to give you trichloromethane, and then trichloromethane reacts with chlorine again to give you CCl4, tetrachloromethane, and you also are getting hydrogen chloride gas. So your products are not pure. The reaction of alkenes, first you have combustion, you get carbon dioxide and water. Let's have a look at addition reaction. If you have an alkene and you're reacting it with bromine, so ethene plus bromine react together and you get 1,2-dibromoethane. The double bonds break and this bromine attach to both of these carbons, as you notice here. You call this as 1,2-dibromoethane. Why? Let's see how. The central chain is ethane, and then you have two bromine, right? So it's called dibromo. The first bromine is on the first carbon, and the second bromine is on the second carbon. That's why it's called as 1,2-dibromoethane. You can also attach it like this. Then that would be 1,1,1-dibromoethane, because both of the bromine are on the first carbon. If you observe the color change, it changes from brown to colorless because the characteristic color for bromine is brown. You don't have bromine anymore, the bromine liquid, so it changes to colorless. In addition reaction, only one product is formed. Unlike substitution reaction, you only get this product, and then the unsaturated hydrocarbon here turns into a saturated product. The double bond is lost. Okay, remember, addition reaction is also called as test of unsaturation, because only unsaturated compounds undergo addition reaction. And if you have an alkane, you won't observe anything, but if you have an alkene, the color changes of the bromine changes from brown to colorless. Cracking is a process where complex hydrocarbons are broken down into simpler hydrocarbons. If you look here, you have a huge hydrocarbon molecule and it cracks. You can get a molecule with any amount of carbons, but you have to make sure that they add up. Okay, 6 carbon plus 9 carbons, you have 15. Okay, you can even have 8 carbons and 7, they also add up to 15. The conditions for cracking is you need a very high temperature, 500 degrees Celsius, and the catalyst is Al2O3 or Cr2O3. You can try to do this example as well. If you have C20H42, what would you get? The advantages of cracking is that it conserves natural resources. Sometimes hydrogen gas is also formed. When hydrogen gas is formed, one of the molecules must be an alkene because they're losing the extra 2 hydrogen, and this hydrogen gas is produced. Also, you can get a mixture of alkenes and alkanes. In this example, both of them are alkenes, but in the previous example, you have an alkane and an alkene. Now let's look at some reactions for alcohols. We'll focus on ethanol. How is ethanol manufactured? There are 2 ways. The first way is fermentation. Basically, glucose solution on fermentation. If you have a glucose solution and you ferment it, you get ethanol and carbon dioxide. So here you have glucose. You basically need yeast and 37 degrees Celsius. The enzyme zymase in the yeast converts glucose into ethanol. The yeast respires anaerobically, helping in fermenting ethanol. You get this fermented liquid and you also get carbon dioxide. This one is cheaper, but this is not very pure and it takes a long time. So what are your observations? You get bubbles of colorless, odorless gas, which is carbon dioxide. Now, in this mixture, you also have your yeast, right? So this yeast can be separated by filtration. What is a fermented liquid? Fermented liquid is basically the ethanol, which is obtained by fermentation. And if you want to concentrate the fermented liquid, you can do the process of fractional distillation. Now look at this example. This is the process of fermentation. You have aqueous, glucose, and yeast, and then you have a water, or basically airlock. So the question is, why would they put an airlock? Basically, this is to prevent the oxidation of ethanol. If you have ethanol, it can react with oxygen and turn into ethanoic acid. To prevent that, you have to put an airlock. And then after some days, the fermentation stops. Why? Because the ethanol that is produced as a product is going to kill the yeast, or maybe the glucose got completely used up. Now, another way to produce ethanol is by the hydration of ethene. So you have ethene, you're reacting with steam, HOH. Now, what are your conditions? You need very high temperature, 300 degrees Celsius, 60 atm, and phosphoric acid, and then you will get pure ethanol. So the advantages of this is very important because you can get a lot of questions based on this. So if you have hydration, what are the advantages? First, you get pure ethanol, right? You only have ethanol here. It's a continuous process. It does not stop. The yeast is not being killed by the ethanol, and also no greenhouse gas formed. Carbon dioxide is not formed, right? There are some disadvantages. Raw material is a non-renewable source, this ethene. The process is expensive. If you notice, it needs a lot of energy. You need very high temperature of 300 degrees Celsius. So that's why you need to have strong vessels that can, withstand 60 atm and 300 degrees Celsius, very high conditions. Now, now you can repeat this again. The advantages and disadvantages of fermentation. It's a cheap process. Raw material is easily obtained from renewable sources, glucose, and then conditions are easy to meet, yeast and 37 degrees Celsius. The disadvantage is that it's a very slow reaction. Impure ethanol is produced. You have to concentrate it using fractional distillation and filter out the yeast. Greenhouse gas, carbon dioxide is formed, and then a large vessel is required. Let's look at some of the reactions of ethanol. The first one is oxidation. So you can have aerial oxidation. That means your ethanol reacts with oxygen. Then you get carboxylic acid, ethanoic acid. Since you have ethanol, you get ethanoic acid. This is not just for ethanol, this is for alcohols generally, okay? And then you also get water. Remember, alcohols oxidize to carboxylic acid. That's important. You can also oxidize ethanol or another alcohol using strong oxidation agent. For example, using acidified potassium manganate. Ethanol, upon oxidation, will give you ethanoic acid and water. Condition is you need to have a strong oxidation agent, which is this one. Another equation for ethanol is C2H5 plus oxygen will give you carbon dioxide and water. This is combustion. Now some reactions of carboxylic acid. Carboxylic acid is a weak acid because it's partially ionized. If you look at this, it's a reversible reaction. You get H plus ions and then you get ethanoate ions. Okay, it's not completely ionized. If carboxylic acid reacts with metal, you get a salt because this hydrogen is removed and sodium attaches here. So you can get sodium ethanoate, and then the hydrogen that is removed is going to form hydrogen gas. These are two more examples. Carboxylic acid, right? It's an acid, so it can react with base or alkali to give you salt and water. These are multiple examples. I'll discuss the first one. The first one is sodium hydroxide. It's a base. It reacts with carboxylic acid. This is ethanoic acid. So you get sodium ethanoate and water. Above, when it was reacting with metal, you only get hydrogen gas. Now carboxylic acid also react with carbonates to give you salt, water, and carbon dioxide. These are three examples. Let's look at the first one. So you have ethanoic acid plus calcium carbonate. Hydrogen is removed and calcium attaches there. So you get a salt, calcium ethanoate, water, and carbon dioxide. There is a question, benzoic acid is a weak acid. Suggest starting materials that can form sodium benzoate. So you can react an acid, so you need to have salt, right? Salt can be formed when the acid reacts either with the metal sodium or metal hydroxide or metal carbonate, and then you will get your salt. The next category of organic compounds is ester. An ester is formed when an alcohol and carboxylic acid react together. You get ester plus water. Let's look at an example. You have ethanol plus ethanoic acid. You have ethanol and then you have ethanoic acid. You're going to remove the water molecule, 2H and 1O. Make sure that you're removing the oxygen from the acid, not the alcohol. That's a good way to write it. You can remember this, that look, carboxylic acid already has 2 oxygen, so it's fair to take an oxygen out of carboxylic acid. You will remove the water and then you will get an ester. Okay, this is ethyl ethanoate. Ethyl comes from the alcohol and then ethanoate comes from the ethanoic acid, plus the water molecule that is removed comes up here. And you also have something called an ester linkage, which is C double bond O and O. Now, what if you have propanol and butanoic acid? Is called as propyl butanoate. Whenever you are naming it, you cannot name it as butyl propanoate, okay? Name the alcohol first and then the carboxylic acid. You can practice these if you want, okay? Just remove the water molecule. Let's consider hydrolysis of ester. Hydrolysis basically means breaking something using water. So now you have an ester. Before, when you are creating an ester, you removed water. So now when you want to hydrolyze or break ester, you will add water. And then you will get alcohol and carboxylic acid back. So you're breaking ester in the presence of H plus and OH minus ions. Look, this is your ester molecule. And you react with H plus and OH minus. H comes here with the carboxylic acid, C double bond O, and then on the other side, you add the OH. You will get propanoic acid because you had 1, 2, 3 carbons. So you get propanoic acid, and on the other side, you have 1, 2, 3, you get propanol, okay? This is another example. You have, this is your ester. So draw your ester first. Look at the ester linkage. This is the ester linkage, C double bond O. So you have two oxygen, that is for the carboxylic acid. So add one hydrogen there, you will get methanoic acid, and then over on the other side add OH, you will get your propanol. And this ester is called as propyl methanoate. You should also be able to name esters by looking at this ester. So here if you can see you have C double bond O, and you have one hydrogen before it. This is made from methanoic acid, and then you have 1 2 3, which comes from propanol. Moving on, let's consider fuels and fraction. Remember, fuels is a substance that releases energy upon burning. Solid is coal, liquid is petroleum, and gas is natural gas, that's main component is methane gas. Fractional distillation occurs when you have a mixture of liquids that have different boiling points. When the boiling point is reached, it evaporates, and then here it's cooled down and comes as a liquid again. Then the temperature is raised. The second liquid that reaches the boiling point is going to evaporate, cool down, and then you will get the second liquid and third liquid and so on. So what you're getting are basically fractions. It's the distillate that separates at a specific boiling point. This is the separation of crude oil. The fractions at the top have lower boiling point, lower viscosity, and higher volatility. They have a smaller chain length. That means they are smaller molecules. As you go down, they have higher boiling point and so on. You need to be able to know the properties and uses of these fractions, which is given here. If you want to know this in details, you can look at the series which is given in the description. Polymers is basically when your many monomers join together, you get one big polymer. Let's say here you had many molecules of ethene. This was your double bond, right? So the double bond breaks, these join together. If you look here, ethene turns into polyethene. You have many molecules of ethene, the double bond broke, and you get polyethene. Another way to write this is that you can write ethene and write N before it. That means you have N number of ethene, and then you get polyethene. So you just write this unit. This is called a repeat unit. You write it here, and then you put a bracket and write N. This is polyethene. The use of polyethene is used in plastic bags, chairs, toys, and building blocks. Okay, some key terms that you should know is that a monomer is a single unit that enters into polymerization. So here ethene was your monomer, and the polymer is the complex structure or macromolecule resulting from polymerization. So polymerization occurred on these monomers, and you got this big polymer. Polymerization is a reaction where monomers in large numbers link together to form a polymer. There are two types of polymerization. What we just looked at was called addition polymerization, because this is a type of polymerization in which monomers in large number link together after the breakage of a double bond. Some common polymers are given here. Now again, if you want to know them in detail, you can have a look in that video. Namely, you have ethene, propene, you also have chloroethene, which will give you PVC. The main idea is that the double bond is broken down and you get your polymer. You also have tetrafluoroethene, which will give you Teflon. You have phenylethene, which will give you polystyrene or polyphenylethene. You have perspex. And then you need to know about the advantages and disadvantages of plastic. The advantages first is non-reactive, cheap, lightweight, good hygiene properties for food packaging. You can have food graded plastic, easily molded, water resistant. It's a good insulator, odorless, and highly durable. On the other hand, it is very bad for the environment. It's created with non-renewable sources. When burned, it produces toxic gas or greenhouse gas. It's really expensive to recycle plastic. It can cause fire hazards. It can burn. It's non-biodegradable. It does not decompose by bacteria. It causes visible pollution, and it harms aquatic life. To dispose plastic, you can first reduce usage. Don't use so much. Use paper or cloth. Recycle, and then you have few more which is mentioned here. Now let's discuss about condensation polymerization. This is another form of polymerization. The previous one was addition polymerization, which was formed by the breakage of double bond. Now in the monomers, water molecule is removed to give you a polymer. For example, in making of esters, making esters, this is not polymerization because you're not getting a huge polymer, right? But the idea is same. Water is removed. This is condensation, and they both join together, and you get water molecule. In condensation, polymerization, look at this. So the first example is nylon. You have this monomer hexane 1,6-diamine, or you can also call it as 1,6-diaminohexane. So you basically have hexane 6 carbon, and you have diamine 2 amine groups NH2 NH2, which are bonded to the first carbon and the 6th carbon. So this is one monomer. On the other side, you have another monomer which is called as hexane. You have hexane in the center, and then you have 1,6-dioic acid. Okay, here water molecule is being removed, OH and OH. You should also remove water from the other side, H2O. So this is your polymer which you're getting. You have hexane 1,6-diamine here, and then NH is over there. This is your open bond. In the center, you have amide linkage, which is this one, C double bond O and H. Because you have C double bond O here, and then you have NH here, right? They both combine together to give you amide linkage. This is important. The second half is the second monomer. This, you have an open bond here, and then you will write N here. Plus, you'll get N number of water molecules. So this is your repeat unit of the polymer. This is repeated N number of times. Some uses of nylon is that it's used in clothing, rainproof jackets, and string in tennis racket. Also, we just discussed the structural formula for nylon. Now let's discuss it in molecular formula. You have NH2, NH2, CH2, 6, right? So you can write this as a block, and then you can mention this as a key on the right side. And then here, now for C2H4, you can mention it as a key again. These are your monomers. You're going to remove the water molecules here and a water molecule here. This is the polymer that you will get. In the center, you have an amide linkage of C double bond O and NH. Plus, you get N number of water molecules. Now, nylon is a polyamide Y. This is because nylon is formed by condensation, polymerization, and it has many amide linkages. It's polyamide. Now, we also have a pterylene. So you have ethane 1,2-diol because you have 2 carbons, and then you have diol, OH and OH on first and second carbon. Then you have benzene 1,4-dioic acid. You have a benzene ring, and on the first and the fourth carbon you have the carboxylic acid. And water is removed from the center, and from the side you will get this. Now you get C double bond OO, so this is an ester link. Now you're getting an ester link. Pterylene can also be represented like this. The key is shown over there. Okay, now we have glucose. Remember, the formula for glucose is C6H12O6. So here you'll write C6H10O4. The 2 oxygen and 2 hydrogen are mentioned on the side. So you will put multiple glucose molecules, and 1 water molecule is removed per glucose molecule. So you're going to remove H and then OH, and then H, OH, okay? So this is the link that you will get. You will have O in between, right? You can represent C6H10O4 as this block and show it as a key. So this is your starch. Now remember, proteins is made up of many monomers of amino acid. This is one example of glycine, which is made up of 2 amino ethanoic acid. These are just examples. You don't have to memorize glycine. So this is one monomer, this is another monomer. Condensation, polymerization occurs. Then you get amide linkage, CONH. You have alanine again. Just remove water molecule and you're getting your polymer. Now let's discuss some important points for protein. The amide linkage, C double bond O and H is always present. Doesn't matter what kind of amino acid you're using. Amino acid, they polymerize to give you proteins. When proteins are hydrolyzed or broken by the presence of H plus and OH, you will get amino acid back. To identify amino acid, you can use chromatography, its preferred way, but amino acid is transparent, so you have to spray or apply the locating agent to be able to see it. What's the difference between nylon and protein? Nylon is synthetic, while protein is a naturally occurring macromolecule. It has many monomers. There's so many different kinds of amino acid. There are actually 20 different kinds of amino acid, and they have different combinations. Whereas nylon has only 2 monomers, diamine and dicarboxylic acid. but both of them have amide linkage. That's their common thing. The general structure of protein is this. So you have C double bond O NH, amide linkage in the center. These depend on the amino acid used. The general structure of an amino acid is this. You have carbon in the center attached to hydrogen. On one side you have C double bond OH, and on the other side you have NH2. And then you have an R group, so this is specific for every kind of amino acid.